Welcome everyone. Today we're here for the HEAT-INSYDE heat storage Q&A. This is our third session, and the topic we'll be discussing today is how is a heat battery integrated in a house? And together with our guest speakers, we'll be discovering the various demo sites where the HEAT-INSYDE battery will be indeed tested and demonstrated throughout the course of the following year and probably a bit longer. So for those of you who are not familiar with the HEAT-INSYDE project, perhaps, just a brief introduction after some housekeeping. So this meeting is being recorded. We will be sharing it on the HEAT-INSYDE project. In case you do not want to be recorded or prefer for certain aspects of the meeting to not be shared, please feel free to inform us. You can see the email address here, info@heatinside.eu, and you're very welcome to get in touch with us. To ask questions throughout the session, and if you would like to intervene, you're welcome to either raise your hand or type your questions in the chat, as you can see shown here. You should have these two icons available in your bar within the Teams software. So now going into what HEAT-INSYDE is and who is here with us today. So we have 5 guest experts, all from the HEAT-INSYDE project. You can see them sitting here with me. And myself, I'm Emily Rose Ciscato, and I will be moderating the session. To start, we have Louison Boulier. He's the heat battery demonstration lead within the project. We also have Marcel van Dooremalen, who's the co-lead for the Dutch demo site. Eva van Enk, also co-lead together with Marcel for the Dutch demo site. Agnieszka Lukaszewska for the Polish demo site. And Bart Erik here beside me, he is the technical system simulations lead. And I will tell you a bit more about each of them in a moment. So starting from Louison Boulier, he's based at CEA. There, he's a research engineer and project manager. Within the HEAT-INSYDE project, as I said, he is the leader of the demonstration sites, so where the HEAT-INSYDE battery will be tested, and he also is in charge of the French demo site. We'll see that we have demo sites across Europe, and this is one of those. We also have Marcel van Dooremalen. He's a senior advisor at Truro at the moment, here in the Netherlands, where we are today. And he is, as I said, the co-leader for the Dutch demo site and has been involved in various sustainability projects also surrounding heat storage and heat harvesting. Eva van Henk, co-leader of the Dutch demo site, is project manager energy transition at the Eindhoven municipality. And she has a background in building physics and services. Agnieszka Lukaszewska here is head of R&D at Fasada. She's been working in R&D for more than 15 years, and she has an expertise in building renovation. As we saw, she's the lead for the Polish demo site. And lastly, but definitely not least, our senior scientist at TNO, Bart Erik. He's also CTO at Demergo, and that is a spin-off in heat harvesting panels generated from the Horizon 2020 project Envision. And we'll see also a bit more about that later today. Within HEAT-INSYDE, he's been leading all of the technical simulations that are necessary to ensure that before going into installing the heat battery in our demo site, we know what can be expected. And so welcome to all the 5 of you, and very much welcome also to those of you following us today and those of you who will be watching this recording at a later point online. A brief mention about what HEAT-INSYDE actually is and what we will be focusing on today. So the HEAT-INSYDE project is a Horizon 2020 funded innovation action. It started in October 2019 and will continue up until March 2024. It involves 14 partners, and these are spread across 6 European countries. The aim of the project is to deliver an affordable, compact, sustainable heat battery solution closer to the market. And you can see at the bottom of the slide here, we have a value chain going from the industrial material production all the way to the market. The partners within the HEAT-INSYDE consortium are spread across this entire value chain, so bring in all the needed expertise to progress the heat battery. And where we are today is actually right here. We will be discussing the demo sites and user validation. And within the project itself, we are really reaching the point of soon installing the heat battery in these demo houses. We have demo houses in 3 main countries, and Louison will introduce these to us in a moment. Those of you who might have participated to our previous Q&As will already know that we had 2 up to this point. The first one was on how heat storage works and why it's so cool. And the second one was on the business model behind heat storage. Both of the recordings for these are available on our website, and there were lots of questions posed by the audience during both of these sessions that have been integrated into the FAQ page on the HEAT-INSYDE website. So if you are curious and would like to know more specifically about these 2 aspects of the HEAT-INSYDE project, you're very welcome to go and have a look and browse through the recordings. Today, however, the focus is on the demo sites themselves and where we stand currently within the project. So I, with pleasure, hand over to Louison, who will tell us a little bit about the overview of these demo sites and what to expect.
So thank you, Emily, for this introduction. So as you mentioned, now we're entering the phase of demonstration. So we want to show that our system is robust and reliable and efficient, and that it can work by users in users' house. And for this, we picked 3 countries for our 4 demo sites. So the 2 first demo sites will take place in Eindhoven in the Netherlands. One will take place in Poland and one in France. And we've chosen those demo sites because of a few requirements. First, it had to be possible to install the heat battery without inconvenience for the tenants, which means we needed space enough to install it and to connect it to the other energy systems that we will present a little bit further. Secondly, we had to be able to use a heat pump on site, and also to install PV panels. And finally, we have to be able to integrate all these systems together to be able to charge and discharge the battery to charge it with the solar energy and to discharge to the house when required. Thank you. So here you can see a quick overview of some of the main characteristics of the 4 demonstration sites. So as you can see, the average temperature is quite different from a place to another. So as you can see, it's a little bit colder in average over the year in Poland than in the Netherlands and in the south of France. The heating needs are also quite different, which will mean differences also in the use of the battery itself and in the behavior and how often and for what purpose we will use it. And finally, the solar PV resource is also a little bit, it varies a little bit from a place to another. So the capacity to charge the battery or to directly use the energy or to resell it to the grid will vary from a place to another. And so it will be really interesting for us to characterize and to monitor the behavior of the systems in those 4 places and see the what differences we will see in the behavior of the heat inside the heat battery. So for just a little piece of planning, as you can see, we will start with the first proto. It's coming in the few next weeks. It starts in Eindhoven before the end of this year. After this, second proto will be installed also in another demonstration site, also in Eindhoven. Then during the Q1 of 2023, we will install it in south of France, and finally in Q2 of the same year, we'll install it in Poland. And these are the demonstration sites that we'll present in more details now.
Thank you very much for this overview. So let's jump right in, and we can start with having a look at Eindhoven and what the situation is there. And since we have Eva van Henk from the municipality of Eindhoven, she will tell us a little bit also about the policy behind heat storage and what the case is for Eindhoven itself.
Yeah, thanks for the introduction, Emily. Yes, municipalities have an important role in coordinating the heat and energy transition in order to reach our climate goals. You see them on the slide. So we have to reach 95 CO2 reduction by 2050 compared to 1990. And also we have to get rid of the fossil fuels. And that's meaning for the city of Eindhoven that we have to sustain more than 100,000 houses, of which 45% are owned by private house owners, and the rest are mainly by social housing, and also 80% for rental, private rental. And if you look at the left, you see a map of Eindhoven, and you see that we have two heating networks at the moment. One is owned by the municipality itself. It's located in Meerhoven, and the other one is owned by a private company called Natuurlijk. And those networks are currently using biomass as a heating source. So we're also looking at different heating sources that are more sustainable. So you can think of residual heat, but also geothermal energy or thermal energy from surface water. And there you see the star where the demo location is located of Eindhoven. It's located at a low temperature network of Natuurlijk. And that was done because we wanted to test the HEAT-INSYDE battery at different system configurations. So here you see the process for selecting the demonstration site. So we first sent out a flyer to approximately 30 households, just talking about the project and what is in that for them. And out of the 30 households, 9 people indicated that they were interested. And due to the pandemic, we weren't able to organize the events, so we conduct interviews with all the interested house people. And after we've spoken to the requirements, because they need at least 1 square meters of footprint in their basement or near their existing installation, 4 of them were still interested. And we invited them also to see, and you see it on the right side of the slide, to see the first prototype of the HEAT-INSYDE battery. And we were also able to get some feedback from the potentially end users. And one of the feedback we got from the tenants was that they wanted to have a smaller size in total. So that's what the consortium worked on. And in the timeline, you will also see, which was already said, that it will be installed in Eindhoven in Q1 of 2023. So in the end, you see, this is the house we picked. That was based on the ease of installation, but also the potential energy savings we could reach with this house. It's recently built. It's built in 2014, and it's connected to a low temperature heating network. And we will place additional PVs. There are already some PV panels on top of the highest roof, and then we will place roughly 8 additional PV panels. And there was already a heat pump inside of the buildings. So as I said, one of the main reasons for people to participate is that they want to contribute to the energy transition. So that's a very positive aspect. And most of them also had the wish to become independent of the heat supplier. That's not the case at this moment because the HEAT-INSYDE battery is an add-on in this situation. But hopefully in the future, it might be an option to become independent and produce your own energy and storage at your own place. And some of the feedback we got from the end users is, as you see also on the picture, they are very nice houses. So they want to have the installation not visible from the outside, meaning the PV panels, but also the HEAT-INSYDE battery. And they really like the modular principle that you can also increase the height of the battery or make it larger or bigger. And one of the things they they took with them for the next prototype is to reduce the footprint.
Thank you very much. And still staying in Eindhoven, we have a second site, which is actually the one that will be installed as the first one. And so, Marcel, I leave the word to you to introduce this for us.
Thank you, Emily. For the second demo site, we picked a typical social rental house. It's a terraced house with 2 floors and an attic. There's a living and kitchen on the ground floor, and a bathroom and 2 bedrooms on the first floor. And we're making this house gasless by insulating the cavity walls and the roof from the inside. We're replacing some windows, front and back door, and improving the air tightness of the whole house. And heating will be done by a heat pump, including the heat battery. On the ground floor, there will be floor heating, and in the bedrooms and bathrooms, there will be convectors. And to save space in the not so spacious social rental house, we're going to place all the insulation in the shed in the backyard. We call it the heat shed, and that will contain the heat pump, buffer and boiler vessel, and the heat battery. The shed will also be equipped with heat panels. And because of that, the roof of the house stays available for PV. And from the shed, underground pipes lead to the back of the house, where they will be connected to the heat circuit of the house. On the next slide, you can see the heat shed. It's now standing on the grounds of the university, where it's all prepared. It contains all the installations, as you can see. And from here, we'll take it to the demo site. This is another house where we've placed a shed similar like this one. We placed it here last year. The shed will be towed by a crane over the house and placed in the backyard on a small foundation when all the pipework is in place. The 2/3 of the shed will contain the installations, and 1/3 of the shed is available for storage room for the tenant. And the installations can be approached from the back alley for maintenance. So that's our plan for the second demo site.
And this is actually a rendering of the heat shed,
Yeah.
right? So you can see it from different perspectives and also put it into scale. See the pallet on the ground there. And yeah, this helps you hopefully get a better idea of what the smart heat shed will look like. So thank you very much.
To give an idea of the dimensions, it's about 2 by 4 meters.
Great. Thank you. And if we then look at the next demo site that we have in line, we have the one from Poland.
Yes,
So,
a little bit more far away located and in also a little bit colder climate. So just make an introduction. When we were looking for the appropriate demonstration site in Poland, we decided to go and to use the building, the social house building that belongs to the city of Gdynia, because also I think similar as for the municipality of Eindhoven, for the municipality of Gdynia, it's very important are the sustainability goals. And also in general, the policy is to increase the independency from the fossil fuels, as Poland is very much based on that. And I think in general, also the situation that we have actual only really confirms that the selection of this building and this goal that we are realizing with our project is appropriate. So our demonstration building, it's an old building that was constructed in 1943, but the building was renovated in 2016. The external walls were insulated. And also for the HEAT-INSYDE project, the municipality decided to insulate the basement walls, insulate the roof. And the plan for this demonstration site is to install air water heat pump as an external unit and PV's photovoltaics that we will install on the roof, and the storage system that will be installed in the basement.
When it comes to the challenges and the requirements, for sure, it's a little bit more challenging when we want to install renewables and also heat storage in older buildings, because we have to adjust the building to the needs of the equipment and to the system. So, for instance, firstly, the building should be insulated, yes, in order not to lose a lot of heat. We need to have a room or area for the tanks and for the heat storage. We should have 3 phases electric power supply, which now the city of Gdynia is working on. Also, the connection power of the building should be higher than 12 kilowatts. It's important to have connection to fresh and domestic hot water and heaters in a place in which we want to install our system. Sometimes also it may be needed some extra piping or electrical work. Nevertheless, I think what is important, that still the amount of the work that you have to do is nothing to be afraid of. It's feasible, it's relatively short, and later the benefits that you may have definitely are worth. So this is more or less how it looks, the situation for Gdynia, and our plan is to have the installation of the heat storage within next spring 2023.
Excellent, thank you. So very different sites again in Poland. And to wrap it up and close our tour of the demo site, let's see what we have in France. So Louis-Antoine, over to you.
So the house you can see here is located in Cadenet in south of France, and the owners are living in the house. The building was constructed in 1984. There is already air-to-water heat pump that is installed in the building, so this is something we don't have to add to the system. It's already there and working for years. We will install PV panels on the roof, and of course the storage that will be in the basement. One particularity of this demo site is that the storage will ensure both hot water but also space heating. And this space heating will be ensured by a hot air blowing system that will that is already being installed on site. So the picture you can see here on the right is the air blowing system that is already on site. And this innovative system is proposed by our partner VMI, which is part of the HEAT-INSYDE consortium. And these systems, which is able to work with both the normal heat pump and also the heat storage. The system allows to filter the pollution by particles inside the house. And what to say more to this demo site? Yeah, one of the challenges also will be, as I said, to install the battery in the basement, because the access will be quite difficult, and we have to really think about how to deal with the hydraulic connections and the integration of all the systems together. But I think this is something interesting, because in a lot of private houses or flats, this will be a real question: how to integrate everything and how to install this battery. So I think it will be a really interesting challenge to see how we could efficiently and quickly install everything for the less inconvenience for the owners or the tenant.
Yeah, that's a very important point, and thank you also, Louison, for your overview. So you see that we have 4 different sites, all quite different, and of course in diverse climatic situations. So what are we trying to get out of these 4 demo sites? What are our expected outcomes?
Well, the main aim, of course, is to have some energy gains for each of the house by installing a battery. That can be done in different ways. For the houses, we decided to use the heat battery to produce the tap water temperature and energy. So what normally happens if you run a heat pump, that a heat pump does not like to make high temperatures for the tap water because the COP, which is the coefficient of performance, which is actually saying how much units of energy do I put in per unit of heat coming out of the heat pump. This COP, coefficient of performance, is quite low for making tap water. It's roughly 2.5 if you want to make 57 degrees of water, or even lower if it's making tap water 65 degrees. So if we have a heat battery, we can make this high temperature tap water up to 70 degrees with our heat battery. And it means that we still need the heat pump, but then at a lower temperature of 30, 35, 40 degrees. And this already means that we have a lot of energy savings for that. So that's one aspect. In another aspect, we also know that net metering, annual net metering is not standard throughout Europe. And that means that if you produce a lot of electricity during very sunny days, you kind of sell it back to the electricity company, which pays a relatively low price if you do not have net metering. So in the Netherlands, we have net metering up to the amount you use, but that's also going to change in 2-3 years from now. So what you could do is, if you have overproduction and you're not using this harvested energy, you can start charging your battery. In the demo houses, we are going to do that by using this electrical energy of roughly 3 kilowatts to discharge the water from the salts, the salt-based heat battery. So we take off the water by blowing hot air in it. And at the same time, we not only charge the battery, but we also create then high temperature water, which we can use for some part of the year for heating, but now also for tap water production. So then when there is a high amount of PV, you don't get any money back, but we store it then into the battery so that we can use it again at a later time, for instance, in the night or several cold days after each other for producing then the tap water. This means actually two things. So we improve it based on the COP, but also improve our self-consumption of the total energy. And both aspects, of course, then also mean something to the electrical connections needed from the network, because the COP is higher. Of course, we need less electricity than from the grid, but also if there's a high solar input, then we're not sending a lot of electricity back into the grid, but we are actually using, and in this way we can balance, let's say, the load on the network, which helps us because in a lot of areas we cannot enhance or enlarge the network at the moment. So it allows us to kind of become gas-free, allow us to go to electrical way of heating with a heat pump without enlarging the network. In that sense, also, if we are efficient, sometimes it can also help to do a little bit less in the renovation. So if we want to install, for instance, heat recovery unit throughout the house, it's kind of quite difficult. If you have tenants in, you have to go through the whole house, drill holes in every room, enter every room. So by improving the performance of the heat pump together with the heat battery, it might not be needed to do that level of renovation. Of course, it's also always wise to insulate your house better and make it airtight and using HR++ class. But of course, you can balance this in terms of solving it more with a heat battery or heat pump versus doing a very deep version of renovating your house. So what we will see in the HEAT-INSYDE project is whether what we expect that will come out of this project will actually happen. So yeah, this is what we expect, and we hope to show exactly for demo houses how large the impact is on each of these points.
Great. Thank you very much also for this nice overview of what we expect. So before opening the floor to the Q&A with our participants today, one first question to you, Bart, just to lead into this is, over what time frame are we going to test and demonstrate the heat battery in these 4 demo sites? How much time do we need to get an idea?
Yeah, now first of all, you should at least demonstrate 1 year to see all the seasons and the aspects of the seasons. So we hope to start in Q1 and Q2 of next year with the demonstration, and at least do a 1 year round of monitoring, and probably in some of the houses, if the heat battery is operating as we expect, we might leave the battery for even long-term measurements so that we can also understand the long-term performance of the heat battery. But that has to be decided based on the quality of the results of the first year. Of course, it's the first time ever we are going to install such a thermochemical-based heat battery in a house. So, of course, there's some uncertainties. But if it works, then we can extend some of the demos.
Great. So at least 1 year to start with, and then we might also see what the future brings beyond the HEAT-INSYDE project. And in terms of the the consumption reductions or the efficiency that we're expecting to see from the installation of the heat battery, can you give us, maybe you have an idea of what we're expecting? Maybe some numbers.
Yeah, I think we have to wait till the results of the demonstration phase, of course, and it also depends on the system configuration of each demo location. But in general, we expect a savings of 20%, more or less.
Okay, and is this across the different countries, or do you think that it will vary much depending on the location?
Well, I think for the Eindhoven case, it will be more or less the same, but I think for the different climate, it might change a bit, but I think it will be in the order of 20%.
Thank you. And yeah, we saw in Eindhoven, we have 2 very different demo sites, and in the first one that will be starting very soon, we also have a smart heat shed. So can you tell us maybe a bit more about this smart heat shed, Marcel? And is this a product that will then be available also on its own on the market, or what is the outlook for that?
I don't know if it will be on the market. That's something for the producer. But now, as you can see, the heat shed, it contains all the installations. As I said, the heat pump, heat battery, boiler, and buffer vessel. The placement of the heat shed in the former house showed us that with the heat shed, you can make a house completely energy positive. So that was yeah, more or less a plus for us that we didn't expect. So you can, with a shed like this, you can make a regular house, a regular insulated house, energy positive. So that's, I think that's very positive.
And does the house need to have a specific starting energy level, or can this vary?
We think a label B would be sufficient, and maybe, but that should come out of the demo sites. Maybe label C or D is also good. But label B is definitely okay.
And then we also saw, Agnieszka, that some demo locations are quite older buildings and need more invasive renovations and restructuring. Can you then say that hopefully from this experience, we will be able to install the heat battery across a much larger range of types of houses? And also then in older buildings, this should be hopefully feasible, right?
Yes, I think with our demonstration, also this is the goal, that it's possible to install the renewables and heat storage on the building that are old. And as all we know, we have plenty of such buildings in European Union. So we don't only have pretty nice buildings that are perfect for the RES installation, but our in general problem, and this is also why we have this project, is that European Union puts emphasis on the renovation and transition of the existing residential buildings. So definitely with our buildings, we want to show that with certain preparation that also are feasible, you can install new technologies on the buildings, and you see the benefits, yes, for the building owner, but for sure for the occupant that is living inside.
And then I guess for each building, it will be a special in its own case. But in the case of the demo site in Poland, how much preparatory time are we putting aside before the battery can be installed?
For our demo building, it's around 6 months, but also it's you have to take into account that there is some paperwork, so agreements with the energy companies, and also this takes time. So in total, I would say that it's around 6 months.
Okay. So
which is quite, I think, good period. Also, if you take into account in general the renovation process, because always it takes sometimes the agreements. Yes, it's.
And in this case, for the demo site in Poland, the tenants are still able to inhabit the house. And
yes, this was also our the condition, because this is the Polish, I would say, in general, specific condition that the tenants want to live inside. So the work that we are doing inside must allow them for that. So they are generally relatively, hopefully, they will be rather short and not so tiring for them.
So not too invasive.
Yes, and not too invasive, definitely, yes. So like a normal, I would say, renovation, yes, from time to time, I think everybody of us has such a situation that need to, I don't know, or redecorate the room, or we are doing something. So it's not like something really to be afraid of.
I think that's hopefully something quite encouraging for
Yes.
folks who are listening and following us. So yeah, thank you for telling us a bit more about that example. And I see now we also have a question from Georg. Thank you for joining us. Georg is asking if there will be a demonstration site also in Germany. So Wissam, maybe you can address this question.
Actually, this is not planned for now. The demonstration site will only be the 4 ones we will show now. And as I explained a little bit earlier, those demonstration sites should be sufficient to see a little bit largely what are the different cases and possibilities in terms of weather, energy, different energy systems, also the use of the energy. So, and as Bart mentioned, maybe we'll be able to have at least 1 year of operation and monitoring for all the systems, and then maybe even more for some of them. And so with all of this data, it should be sufficient for us to fully understand the system we are making and installing now.
Maybe for follow-up.
Yeah.
Maybe for follow-up.
Yeah, so I guess related to that, we have an outlook to where the HEAT-INSYDE battery will be on the market and when this will be. And I believe we have expectations that this will start from 2025 onwards. Is this correct?
Yes, but as you know, I work for TNO, and the heat battery probably will be put on the market by spin-off company Celsius. So I think that the 2025 would be a good indication. However, depending on the economics, which we will find out in a demonstration site, you can think of installing the battery in a single house. But if you look at the demo site in Poland, it's actually 2 stories high building with in total 6 houses, 8.
Yes,
8
so in
apartments.
a row, yes.
Yes. So in that sense, it might be more economic to make a kind of local network to use the heat battery. Because if you scale up, it's modular, as was on one of the slides, and that helps really to get the economics down, because you just add some thermochemical material to the battery. And one of the aspects we will find out by this demonstration is what is the total gain. Also, the whole situation when we started the project was totally different than now, where we have skyrocketing prices for gas and electricity. So that would mean that we will learn also how this affects the whole energy system and the prices going along, and that also influence the business case. And I think there are some pictures also. You saw the shed. This is the first time you install a battery, so there's a lot of development to possible to reduce also cost of the whole installation. So making a suitable business case requires also several steps in development of the battery.
So to get back to Gail, who asked the question about Germany, seems like a bit more patience is needed in this moment. So we do have the 4 demo sites selected and planned to progress as such. And then there might be opportunities, hopefully, of course, in the future for further demo sites at a more advanced level, and maybe also for the heat battery itself in the near future. And another point that you mentioned, Bart, with the business case is that in the case of Poland, we have multiple row houses. And a question we had coming in previously was, is it possible to also use this solution for, say, a condominium, a setting where you have multiple apartments, even 30 or more apartments? Is this going way out of the possibilities?
No, no, I think that's a big opportunity there for installing heat battery. One of the most effective cost parts of a heat network is the pipelines from the source to the delivery site. So if you could install a local battery which kind of charges discharges, then you can heat the houses there. And we have a lot of energy available in all kinds of chemical processes. So if you can charge locally the batteries and then bring let's say the charged battery cassettes or modules to the location where these houses are, you can even use all this waste heat we have for all kinds of processes to heat up urban areas, houses, condominiums, rural dwellings, even whole areas with this solution. But that means that we still have to make big steps for that, but there's a good chance of doing that.
Great, thank you, Bart. And I see we also have another question from Victor. Thank you, Victor, for also joining us. So you say, I see PV electrons as source of local renewable energy, e.g. energy shed, Trudeau. Question, will you also implement heat from PVT and or solar collectors? PVT typically delivers in joules, more in heat than in electrons.
Yes, shall I take this question? Well, in the heat shed, we use thermal panels to harvest the heat so that we can use the roof of the house for photovoltaics. And indeed, it's true that per square meter, heat harvesting panel harvests more energy than for PV. In this case, for the heat shed, if we have a special white, which was developed in another European project, then we have 40% of solar harvesting. Until a dark color like black, we have 95% of solar harvesting. If you use the thermal panels, you can gain a lot of energy from sun and from air driving the heat pump. Also, PVT is a good option. Unfortunately for PVT, there are some downsides if you combine thermal aspects with PV, because you can have a lot of condensation or freezing, so that the PVT becomes a little bit more efficient, and also because the connectivity is a bit lower of the glass PV, sometimes it's not so effective. And there's also might be a risk on the combination of moisture and electricity, depending on the type of PV panels. But indeed, it's also possible to combine it with PVT or thermal solar collectors.
Okay, thank you very much. And we also saw in all of these cases that we usually have a heat pump and PV connected. So these are must requirements, or do we always need a heat pump?
Well, the heat battery is based on a principle where you hydrate the salt with water vapor. So there should be a source to create the water vapor. You can do that with a heat pump, of course, but if there is a ground source or a local low temperature network, as in the municipality of Eindhoven, that can also be a source of this water vapor. So then you would not necessarily need a heat pump, but it also means that you have to enlarge the heat battery. So the heat battery, it cannot supply the energy for the whole winter. So still you have to balance it. So in most cases you need then another source. But you could also think of a hybrid solution with gas heaters. But generally now in most of the applications you will need a heat pump. Yeah.
Okay, thank you. And since we're talking about sources and how everything is connected, in the smart heat shed, in the case of one of the Eindhoven demos, the heat shed is placed at the end, or we saw in the model, it will be placed towards the end of the garden. So how will that be connected to the electricity in the house?
Underground pipes.
Okay, very simple then.
Very
So
simple. Yeah.
nothing that obstructs the living situation of the tenant. Thank you. And
Emily, I see also a question from Francesco.
Okay.
Maybe we can address that.
Sure.
How heavy is the battery, and does it make a lot of noise when it's on? Well, there's no moving parts except some valves opening and closing, and we blow air through the whole system. In principle, there should not be any noise problems if we blow the air through. That's a matter of designing the flow in such a way that you do not hit sharp edges, and that would create noise. But in principle, that can be avoided. The mass of the battery depends on how much modules you add. And I think there was on the website some numbers in the Q&A answer from last sessions, but if out of the top of my head, this battery would be in total with installation about 1,000 kilogram roughly.
Okay, thank you. And Tino, thank you. We see that you send us your greetings. Thank you also for joining us today. Tino had the chance to see the heat shed during the HEAT-INSYDE workshop that we hosted here in Eindhoven a couple of days ago. So he also probably asked all of his questions at that point, but thank you for still joining us. And another aspect that is quite important when we're considering installing a heat battery in a user's house is how is this heat battery gonna work? How will it be maintained? And how will the user need to interact with the heat battery itself? Maybe Agnieszka, you have an answer to this. So how much burden could this be on the user?
So the plan is that, and the idea, I think, for the whole heat storage is that the tenant doesn't need to operate. It's like operating remotely. So it's just the system is working and you don't interact with the system. So I think it's very convenient for the user of the system, yeah? That it's in general, the system will require internet connection and there is like some communication between the heat pump and the heat storage, but no extra work is needed or assistance from the occupant side or the tenant or the person living inside.
And what if something goes wrong with maybe there's a connection that isn't working properly, or there is any issue with the heat battery? What happens then?
Is still the heat pump will be operating, so also the tap water and heating will be supplied and will be working. So our system are designed in such a way that if the heat storage, I think this is also very convenient, yes, for the user, because as everybody, and it's normal that people on one side, we want to be independent for fossil fuels. And I think especially what happened now with the war, we really want to rely on ourselves, yes? So it's really a very good opportunity to have this system. And as it doesn't require from a user any interaction, or it can work. And also in case the heat storage, something is broken or something will be not working as it should, the heat is supplied still.
Thank you very much for that.
So it's worth to be like living in the demo sites, because I think really we are putting all our efforts that they are on the safe side. And I think this is very important, that you can trust the technology, yes? With the new technology, we have to build this trust. And we want to show it with the demo site. So I think our, for sure, next Q&A and event, and I would like to invite everybody who will also in future will watch this Q&A to track what we are doing, because I think ahead of us are plenty of interesting things, and also to see how it's going on and dealing in reality.
Thank you. Yeah, definitely. We have an exciting year and even more ahead with the start of our demo site. And we are also almost towards the end of this Q&A. So before closing, I would like to ask if any of you have any final concluding remarks or other points you would like to bring up in relation to the demo site while we're here. And otherwise, I will try and wrap up for us today.
I can have one comment. Like, I'm very glad that in general with our project, we are showing that governmental or public or municipalities are interested in that direction, yes, in renewable, in heat storage, in sustainability. I think this is a strong point of our project and in general of these technologies, because I think the public buildings can be, or social buildings can be also good example of the direction in which we can go, because sometimes private maybe owner can be a little bit afraid, but if you have a neighbor or somebody that has tested the technology and is satisfied, this is like the best advertisement. So I'm very glad that for the cities that we have, they are interested in that sustainability direction, and it's great. We should go, in my opinion, in that direction.
Yeah, thank you. And in fact, we have Eva here, which is the best.
Yes, exactly.
From the municipality of Eindhoven, and here
City of Gdynia also.
Yes. Is also owned by the municipality, yes. Right? So yeah, very good examples, and we hope that these will also continue in the future. So thank you very much once again for joining us today and for answering a few of these questions. that we have around the demo site. Of course, as we said, as we are about to start installing the first the smart heat shed in Eindhoven, and the next demo sites will follow in the coming months, we will be updating you either through the following Q&A, but also on our website and on our social media channels. So do keep up with us and have a look from time to time. You will be, of course, invited to our following Q&A sessions. These will take place in the next year, so in 2023, once we'll have the opportunity to give some first insights into what these demo sites have taught us up to this point. So with this, I would like to conclude. Thank you to those of you who joined us today, to those of you who will be watching us as a recorded Q&A session, and thank you very much to all of our guest speakers. And we'll be seeing you all very soon. Thank you and enjoy the rest of your day.